Welcome to Chapter 10. This is the video for Exercise 1, and it's focused on timing how long it takes your computer to implement LU decomposition. LU decomposition is computationally intensive, and so therefore people often use LU decomposition basically just to test the efficiency of their operating system and their machine. So here I write, out of curiosity, I tested how long it took Python and MATLAB to run LU decomposition. This is two different programs running on exactly the same computer. So I ran it on my same laptop. This was a local installation of MATLAB and a local installation of Python. And what I did was run LU decomposition on a 100 by 100 random matrix, and I repeated that 1,000 times. So 1,000 100 by 100 matrices, LU decomposition, and then I just tested how long it took. So MATLAB was around 1/3 of a second, Python was slightly longer, and then I tested it again, exactly the same code as on my computer, but this time using Google Colab. And at the time that I wrote this book, that was around 1 second. It took around 1,000 milliseconds for this LU decomposition, 1,000 matrices of 100 by 100. Okay, so now the objective of this exercise is to see how long this takes to run on your computer. So nothing really fancy about linear algebra theory or concepts of this exercise, really just about making sure you know how to clock computation time on your computer to help you evaluate the efficiency of your code and of the computer you're working on. So the code is pretty simple. I've actually used this earlier in the book. So if you look back, I don't know which video it was, but in some other exercise in an earlier chapter, I introduced you to this module where we can take a piece of code and wrap it inside two calls to the time.time function. And yeah, basically this tells us the system time at this moment and the system time at this moment, and then we subtract the start time and so on. And then we get the result in seconds. You could multiply it by 1,000 to get a result in milliseconds. So just, 1,000 times we repeat these two lines of code, which is just to generate a random matrix and compute the LU decomposition. So let's see how long this takes now. So pretty interesting. This time it took actually half a second. That was faster than when I ran it just before the video. I ran it just before the video and it took around a second. The first time was actually over a second. It was like 1.4 seconds. So it's interesting to run this over and over again. You can see I'm mostly getting either a half a second or a second to do this computation. And, there's a lot of deep computer science-y stuff in here. And I admit that I don't totally understand what causes this variability, but essentially, I'm running this code on Google Cloud, and that's a big server somewhere. I don't even know where it is. Buried deep beneath the North Pole, or maybe it's on the moon or something like that to keep it nice and cool. But that server does not exist only to, run my LU decomposition. Servers are doing lots and lots of other things. And so you might get differences in computation time.